Thermal bridges. Thermal bridges are the areas of the home where outdoor temperatures move in and indoor temperatures can move out. It's basically just a highway, a road for things to move in and for temperatures to move in and temperatures to move out. And it's uncontrolled. And the whole point of this is, the whole point of the home is that we're trying to control the temperatures. Any kind of changes we want to be intentional. So if windows are open, great. If windows are closed, we want the temperature of the home to be what the clients want the temperature of the home to be. And there should be no unintended consequences. So we do have, we have very few thermal bridges on this house, and one of the practices of Passive House is to eliminate all thermal bridges. We've tried to do the best we could without making our construction too kind of fandangled or unobtainable to average residential builders. So if we start at the bottom and work our way up, we know that we have a thermal bridge at our slab edge. Though we do have an insulated slab where our footing comes up and meets our slab, we don't have any insulation right there. Our wall insulation hangs down 2 inches, and then our slab is, our insulation is 4 inches below our slab. So we do have a 2-inch little highway right there that is considered a thermal bridge. It's the only thermal bridge that we have in this house. So then as we move up through the wall, we've got exterior insulation. So we have 1.5 inches of wood fiberboard, a Gutex wood fiberboard on the outside of our CDX sheathing. So we've eliminated all thermal bridges that are in the wood framing aspects of the home. Then we'll move up to the window. We have our window rough openings are framed very close. So there's only about a 1/4 inch leniency on the tops and the bottoms. And then we're bringing our insulation right to the edge of our wood for our window. So these windows are actually like an aluminum rain screen over solid timber windows. So we've got about a 1/4 inch gap. Our insulation comes over, there's a 1/4 inch gap in between our window wood, the wood frame which is behind here. We tape the edges for our air sealing, and then we pack the inside gap with either a wool, or in this case we've used rock wool, the stone fiber insulation. So we then move up to the junction between the wall and the roof, and this is a real typical failing point for many projects, for many code projects. You might have, say, 14 inches of insulation in an attic, and then your normal 5.5 inches of cavity insulation, but you've got 2 top plates. You might have roof trusses that don't have a raised heel. So as you get to the point where the roof truss meets the wall junction, your insulation kind of compacts, or you have much less insulation in that area. So what we've done here is we've paid really close attention to eliminating that. Our roof trusses on the inside are 14 inches deep, and they sit on the outside edge of our top plate. So we've run our exterior wall insulation about 7 inches up past the top plate. So where our interior roof truss comes over, and that gets filled with 14 inches of cellulose, our exterior insulation then comes up past the bottom edge of that. So if you were to look at this in a section view from the outside, you would see a continuous path of insulation. It goes right up our walls and down into our roof trusses. And then we've built the outlookers with 2x8. So we've got a pretty good capacity of wall insulation going up the wall, going past the bottom point of our ceiling insulation. So we've eliminated that thermal bridge, which is usually one of the biggest ones you see in like a typical roof truss construction. So that's it.